since I forget who. Oh, now we're recording. Okay, there's Debbie. Melanie looked up that information about the black diamond that hit the news about a week and a half ago. Some of you have heard about it. Some of you maybe looked it up. What did you find, Melanie? Is that what it looks like? It's been carved out of what? An asteroid?
A meteorite.
A meteorite. Okay, what I heard on the news, something about Abu Dhabi. So I'm assuming that's where it fell 1 to 2 million years ago, a meteorite.
No.
Okay, who's that? Regina?
Yeah. No, that's where it's going to be sold. Abu Dhabi is where it's going to be sold.
Oh, I thought so.
There's a Sotheby's.
Okay.
Sotheby's auction house. There's one in Abu Dhabi.
Oh, all right.
Or Dubai. So that's why it's there. And, you know, I would assume that the seller has some link to that area.
Okay. Does anybody know where it was found?
No, I couldn't find anything where it was found.
All right. So in the back of my mind, it's a hoax. But other than that, evidently it was carved from a meteorite rather than something created on the ground when the meteorite hit. Anybody? There's Jordan, can you hear us?
Yeah.
Okay.
Different theories.
So that's what the news was kind of all over the place. So that's why I think it's a hoax, but who knows? This may be something if you're interested in meteorites. And next year when we reconvene, we'll probably do another whole session on meteorites, since I've learned a lot about them since last time we talked about them. Evidently this happens once in a blue moon. Something to do with the carbon in the meteorite, and it's converted into a black diamond. So anybody want to add?
I have more info.
Okay, go on.
Yeah, Regina. There are natural black diamonds found on the earth, but they're only found in Brazil and the Central African Republic. And they figure that's the reason is that those two places have them is because, you know, billions of years ago, they were in one continent, Brazil and that area of Africa.
Right.
And that's why they're there. And they are found naturally in those areas, but they're actually, Popular Mechanics had a good article about it. They call them carbonado. They're actually polycrystalline diamonds. That means they're a bunch of diamonds cemented together by a bunch of tinier diamonds.
Okay.
And they're found in sandy deposits. And that's unusual because the woman from Sotheby's said normally diamonds, let me see if I can find normally diamonds are found in kimberlite rock, and they come to the surface through volcanic eruption. However, these diamonds are found in sedimentary alluvial deposits, which means they're carried down by water. They're found near to the Earth's surface. So this woman at Sotheby's said that the diamond was likely formed after an asteroid hit the Earth and created chemical vapor deposition that formed the diamonds. But, you know, different people have different ideas about it. And one guy from Penn State said that they actually should have, they're skeptical. There's a lot of scientists that are skeptical of the celestial origins.
Right.
And that whoever buys it should get a certificate of authenticity. But one little tidbit of information was, it was in the Guinness Book of World Records in 2006 as being the largest diamond.
Right.
So, you know, Guinness, apparently they certified it if it was in the Guinness Book of World Records.
Wow. They can be hoodwinked also. That was my theory, that rather than being in an asteroid, that when they were testing the atomic bomb out in New Mexico in 45, the great intense heat on the sandy surface created something called, I believe, tektites, which are little beads of glass. The heat converted the sand into pure droplets of glass. So, and I'm not sure if that also is an astronomical effect sometimes. When a meteor strikes, if it's in a sandy area, it creates these little tiny little bubbles of glass. So that was my thought, rather than it being inherently a part of the meteor.
Yeah, could I?
But meteors don't meteors hit all over the world? They just don't hit that area.
Yes.
They hit all over.
Right,
Yeah.
right.
But these diamonds are only found in Brazil and Central African Republic.
And we're assuming this one was found in one of those two places?
You know,
But no-
nobody mentioned that. Nobody said where it was found, and that makes it skeptical. And nobody's shown this diamond before. This is the first time this diamond has been made available to the public, and the guy that's owned it has had it 20 years.
Yep.
And he's never showed it before, and it doesn't really look attractive to me either. However, they said it weighs about the same weight as a deck of cards.
Yeah. Well,
Regina,
okay, go
can I
on,
ask
Bob.
a question? In your research, which I appreciate, did you by chance see anyone having done a chemical analysis of it or the fragments that were taken off? It would be, if it's truly diamond, it's got to be essentially pure carbon with at most some minor impurities. The blackness still surprises me because most of the time when diamonds get a metallic impurity, they're colored in some way. Red diamonds, blue diamonds, I don't know if they're green diamonds, yellow diamonds, but they're clear. This is, now, if there's enough light scattering, if it is true, this argument that it's little tiny diamonds and then held together by even tinier ones, maybe I could buy the blackness.
I'm thinking
maybe.
of somebody's lab, Bob. We should all go
Well,
back.
you just look at it. Yeah, just look at the pictures. It doesn't look like, you would think a diamond would be. It's a lot of hype. This is a lot of hype about this.
Well, and it's also got strange faces showing because usually diamond faces are different from that. But
Well,
I'm no diamond expert.
Should research the Piltdown Man, one of the famous hoax from 100 or so years ago. Anyway, okay, we got to move on. We're never going to get up into orbit. All righty, the black diamond. We got through that. All righty, very quickly, let's go through our assignment questions. Then we'll get to the topics, and then we'll finish with what we're going to do next time questions. Regina, I think, and this was 3 weeks ago now, right? 3 weeks ago, I believe you had the orbit. We're basically talking about the Webb Telescope today. Regina, did you do anything about its orbit at 1,000,000 miles up there in the sky or not?
No.
Okay.
I don't even remember.
That's all right.
I did something on the celestial objects and art.
Well, we'll let that slide.
That I didn't. Yeah.
we'll let that slide for now, okay? Because we got a lot.
Mary Lou?
Yeah.
I sent back to the library an article that was just in the Washington Post that talked about it because it's in place now, right? And the orbit is on the other side of the sun from us, right? But it's our.
Oh yeah, I did do that.
It has to do with its year is the same length as our year, so it'll always be that distance from us. They had some name for where.
We'll get to that.
Whatever
we'll
it
get
is.
to that.
Okay, that's the orbit.
So the orbit, I believe, is about 1,000,000 miles from the Earth, and it's orbiting the sun. Is that right? Rather than us?
Yes.
Okay, so it's like we are, and like
we are,
Mercury and Venus and everybody else.
but on the
It's
exact
become like-
opposite side, so that
Okay.
it sees what we don't see.
All right. Melanie had to look up and provide a picture of the shield or the umbrella, which it was a few days after launch on Christmas Day that they were high enough up that they began to unfold. I'm going to call it the umbrella or the shield. Do we have a picture of what that looks like, Melanie?
Here's
She's working on it.
the sequence of it unfolding.
Okay, here's a sequence, what, from upper left around the
Yep,
corner
this
and
is
down
when
to
it-
the right?
This is when it left Earth. It's unfolding, and then this is what it's fully unfolded.
Now you speak softly. Can you all
Oh.
hear Melanie?
Yes.
Oh, sorry.
Was
So
that,
so that's the sequence of it, and then I do have another picture that Rima shared.
why, guys, do we need an umbrella? It's not going to rain up there.
It's
No.
to keep the heat away from burning it too much.
Yeah. Okay, the solar radiant energy, which I'm guessing, is that so much heat as ultraviolet and X-rays and gamma rays? Is my
Yeah.
guess.
The whole gamut of radiation.
Okay.
And the problem is it would interfere with the detector.
All righty. It would mess up the electronics on board and also perhaps melt something. I'm not sure about the melting part, but
Well, I don't know if it would melt anything, but it would overwhelm the detector with radiation. And instead of getting the radiation from the stars it's trying to look at, it also, the detector has to operate at very, very low temperatures to be
Right.
sensitive enough.
okay.
And you just can't be in bright sunlight.
Okay.
And the difference between the side that's facing the sun and the side that's away from the sun is tremendous in terms of temperature. And
All
it's
right.
essentially, you know, when these astronauts go for their spacewalks,
Mhm.
one side is hot on the outside, the other side is rather cool.
It's like sitting around the bonfire.
Yeah.
All right. So is the gold yellowy part, is that the telescope, and the silvery white part the shield?
Yes.
Yeah.
Yes. Okay.
Bob, these are all the mirrors, correct?
Yeah. Yes. The gold stuff's the mirrors, and
All right.
and there. See those arms extending out from the mirrors. At
Mhm.
the end of it is the actual detector. It's
Ah.
like it is in fact a reflecting telescope.
Mhm.
It's just it doesn't need a tube to get rid of ambient light, and so light from great distances impinges on that set of gold mirrors, and you got a lot of space there because you know, yes, there's, oh, I don't know how many individual mirrors, but they can all be oriented so that they properly focus on that detector at the end of that boom. And so you get a whole lot of light. You know, it's like the big telescopes, Mount Palomar or Mount Wilson. You know, they use gigantic mirrors. And
All right. Okay. Some statistics here. I read somewhere or heard somewhere that the shield, the umbrella, is about the size of a tennis court.
yes.
And then would you read, this is Rima's report about the mirrors, how many there were, what shape they had, and how big they were, I think.
So the main mirror is this gold piece. It consists of 18 gold-plated hexagonal segments.
So stop signs, 6-sided mirrors all put together. How many of them? 26, did you say?
Oh no,
No.
18 gold.
18. Okay.
Oh, there are 18 gold.
Separate mirrors that
Yeah.
all had to unfold to create this one mirror made up of 6-sided parts, right?
Yeah.
Yeah. Okay.
And then there's
Aren't we clever?
and so right now all of these individual mirrors are being adjusted, and it'll take about 3 months to finalize that process. And then there is a secondary mirror that collects light from the main mirror and sends it to the instrument module.
Wow.
Oh, so,
The telescope
so
is,
that. Oh.
sorry, Bob, go ahead.
No, that in that case, that what's at the end of that those three arms that stick out, that's probably the secondary
The
mirror.
secondary mirror.
And there's a hole in the middle of the main mirror, and the electronics would be, the actual detector and electronics would be behind it then.
Whatever. Okay.
And the sun shield is 70 feet wide.
70 feet wide. Okay. All right. That was Rima's assignment. Let me think here. I'm going to jump around a bit. Debbie, are you still here? We lost Debbie.
I didn't think she came.
Yeah,
Yeah.
she was here.
Yep.
There she is, Debbie. You were
Sorry,
just
I was muted.
okay. You were supposed to tell us why do we spend all this money and effort and hand wringing to get this thing up there? I'm a million miles away. What's it supposed to be studying?
So I think that it is using infrared
Yep.
wavelengths, right?
Yep.
And so the object is to look inside dust clouds, because that's where stars and then the planetary systems that form are found. So look inside dust clouds, look for the first galaxies that formed after the Big Bang, and then look at how those galaxies have evolved or changed up until now. Try and observe how stars form. And then after you get the star, which would be equivalent sort of like to our sun, how the planetary systems form around the star that form. And then ultimately try and investigate for potential life in the galaxies or the stars. So the planetary systems that formed around the stars that formed in the dust clouds.
Okay. Okay, let's go back a couple of sessions when we first looked at that electromagnetic spectrum with our little narrow band of visible light, and how we were limited until around 1950 at only looking through our eyes. And then we began to use other bands on that electromagnetic spectrum, infrared being one of them. And the magic of either sound waves or infrared waves,
Radio waves.
radio waves. Thank you. Radio waves or the infrared rays, they can see through the dust.
Right.
Magic. And they can see what lies beyond it. So we can explore what's behind the dust clouds. But what I think is really, really interesting, even more so than looking for a life out there, is it's like a geologist looking at fossils. And as you go through the millions and millions of years, the fossil record changes, and you can see how individual species change or evolve over time. And so with this telescope, we can go back about 13 billion years, which is only about a billion years from the birthday, from the Big Bang, rounded off. And we can compare those ancient old galaxies from the beginning of time to the ones closer to us that are younger, and see how they have changed. So you can see then, by examining these galaxies through space, through time, it's like the evolution of the galaxy and the stars within them. So, okay. Jordan, you still there? Jordan has a lot of catch up to do. All right. What I want to talk a bit about orbits and how we get a rocket from sitting on its pad. And by the way, Jordan, you're going to have to hang in for a minute. Do we still have Cindy's 2-minute?
I emailed it to them all,
Oh,
so they'll have to watch it on their own.
okay. Melanie, my friend Cindy, who used to run Chicory Station in Hornell years ago, teaches now. So she would be an avid member of this group, but she teaches. So she's she's with her kids now out in Ohio. But we got talking last weekend and she just got off on this excited binge rant, whatever, about the time she went down to Cape Canaveral when they were supposed to launch something or other. And then, of course, a thunderstorm hit and it didn't launch, but she was still there. It was like a rock concert in the crowd with all the excitement and the patriotism. And I thought her little 2-minute bubbling up was so interesting that I had her email it. And Melanie has emailed it all to you. So you should have it. And sometime later today, you can listen to it. Okay.
Mary Lou.
Yeah, it didn't work for me.
It
I
didn't.
tried it.
Okay. Because I couldn't get it to play with the Zoom. So
Format.
yeah. So we might have to ask her to resend it. Because I couldn't get it to so we could play it while on Zoom.
Okay. Did anybody else?
But you were able to see it? Because I went
Oh,
on
just
Zoom.
hear it. Just hear it.
I didn't hear anything.
Okay.
Maybe the sound was off. I could try it again.
Did anybody hear it?
No, I didn't try it yet.
Didn't try it. Well, we'll leave that hanging for now. And if you can manage to hear it, great. Otherwise, we'll get some technical person figuring it out and we'll be able to play it next time. Because just like Regina telling us about being out there on that boat in the Pacific and seeing the green flash, it really, I think, is important for us to share our experiences that we have had. And so we'll put that on hold. All right, Jordan, back to you. You still there?
Yeah.
Okay.
Oh, I had audio for that Zoom link.
You do have audio.
Yeah,
So
I can hear it. I just opened it.
All right. Now, if you play it, can we hear it?
I don't have speakers, so no.
Okay. All right. We'll let that go then. Well, one person could hear it. All right. In a few minutes, we're going to talk a little bit about orbits and trajectory and how do we actually get this thing up there 1 million miles away to a very particular spot in space, which we will talk about. But Jordan, why don't you, you had a whole bunch of things. Let's start with Napoleon. Jordan's our historian, so I always stick him with the historical information.
I thought I was going to say that after you said your other thing.
What's that?
That was related to it.
I'm running a blank. What do you want me to say?
Truman.
I'm sorry, what?
I thought I was going to say that after you talked about Truman.
Truman. Well, Napoleon lived before Truman, so why don't you talk about Napoleon first, and then tell us about Tesla and his car, okay?
Okay. Well, I guess the thing I had to say about Napoleon was just about how he was an artillery officer in the French Revolution. And I don't think he did it as much later because he had other stuff to worry about. But I know one battle that he had a lot to do with the artillery was in the Siege of Toulon. I think that's how you pronounce it. In 1793, it's a French city. And he was an artillery officer, so he took over personal command of the artillery, like doing the mathematics on where to fire. And he did a lot of that in that particular battle.
Okay, I did not know that. Hang on to Tesla for a minute. If you're a pitcher for the Yankees, you have to know everything about orbits. You have to get that ball from your mitt right where you want it to go over the plate. And all sorts of things affect that. How much energy do you have in your arm when you throw it? How heavy is the ball? I'm assuming the balls all have the same weight in the game because it'd be cheating otherwise, right? You have to take into the fact, once again, the plate probably is exactly a certain distance away, but the wind is something that affects things. So the same thing with Napoleon as an artillery officer. And some of you may know this, Harry Truman, who really should not have been commissioned for the First World War. He was a bit older and his eyesight wasn't very good. But being Harry Truman, he had some connections and he pulled some strings and he got himself into the army, into the artillery division, and he sailed for France. As a lieutenant, by the time he landed a month or so later on the shores of France, he was made a captain of the artillery. And so, like Napoleon, he was a man that got right out there with his men and saw to it that when you were firing off mortars and howitzers, or even a rifle, you needed to know your math. How much energy was in your gunpowder? What was the weight of the bullet or the whatever, the cannonball in, I guess, in Napoleon's time? What was the wind doing? Because anybody that's ever thrown anything on the earth, you can, even if you throw it basically straight up, the earth is turning. So straight up doesn't stay straight up. It moves. Your feet move, although you're not aware of it. And then the ball begins to curve. And eventually the gravity takes hold and pulls it back down to the earth. So when you have a telescope sitting on top of a rocket and you want it to get to a certain place in space, you have to know the weight, or the mass, really. We call it weight here on Earth because we think of them as the same, even though they aren't. You have to know how much fuel you're using, the energy. You have to aim it such that as it rises up, and I wrote down here somewhere, I think it's on the other side, I think it's 18 miles per second, the velocity of the rocket taking off to escape Earth's gravity, to be able to get beyond the effect of the Earth pulling it back down and crashing it.
Mary Lou, it's 25,000 miles an hour. I'll get that.
Okay, 25,000 miles an hour. I thought that was awfully fast, but somehow that popped up in my notes. So say again, Bob. 25,000 miles
I'm
per.
coming up with essentially 7 miles a second.
7 miles a second. Huh, wonder
Yeah.
where that 18 came from. Okay, thank you for that.
Well, 18,000, well,
Yeah, never mind. Let's not get too complicated. All righty. So 25,000 miles per hour. Is that what you said?
yes.
Okay.
That's minimum to escape the Earth's gravity.
Right. So when our satellites go around the Earth in 1 hour, close to the,
Hour and a half.
the circumference is about 25,000 miles. So if you could drive that fast around the equator, it'd take you 1 hour to go all the way around. Okay, that's pretty fast. So picturing your mind's eye, the rocket with the telescope originally went straight up, but it soon began to curve. And the whole idea was to balance everything so that the curve then became parallel to, I was going to say the surface of the Earth, but that's wrong for this telescope because we wanted to go around the sun. Right. So eventually what they were seeking was an orbit 1 million miles from the sun that would become a circle and would continually, in a sense, the rocket then, or the telescope, is free falling around this circle that's going around the sun at a 1 million mile radius, I guess, from the center of the sun to where it is. That's the radius. And it turns out, you've heard, and I don't know if some people said, I try to find out what it meant, but I don't know what it means. It's parked up there. I call it in a parking lot called a Lagrange point. And here's how and Bob, you can correct me when I'm done, but here's how I'm thinking of a simple explanation for that. You all were kids once in kindergarten. And for me, it was kindergarten. We never had access to a teeter-totter seesaw until I went to kindergarten down in Panama. And because my dad was a Marine and we were stationed down there when I was in kindergarten. And imagine you have a chubby friend and you're a skinny kid, but you want to sit on the teeter-totter and have it balanced so it's parallel to the ground. It doesn't take too much experimenting to realize the skinny kid has to sit further out and the chubby kid has to sit in closer to the center. Otherwise, the teeter-totter is not going to be parallel. So if we can find a point for that orbit where the gravity of the sun is equal to the gravity of the Earth's pull on this contraption, then it continues to free fall around and around. And you don't have to use up any more fuel to keep it going. If it were an absolutely perfect vacuum. And even though it's almost a vacuum, it's not really perfect. So my guess is every once in a while, you have to turn the engine on, even maybe for a second or whatever, to give it a little boost so it continues at that rate around and around. But as long as it's parked at that Lagrange point, you don't have a lot of competition to move it. And what is that? I forget which law of nature. Once an object's in motion, it stays in motion, unless something gets in the way to slow it down, like friction would. So that was my definition of the Lagrange point. There's more than one. Because once again, it's not just the sun and us out there.
So the different Lagrange points are where the gravity of whatever object.
Yeah, and it might be like Jupiter, Saturn, the Earth, and the sun.
Okay.
And since everything moves at slightly different rates going around, that would probably shift. But once again,
Nope.
I want this to be fun and not to get hung up in what was that, Rima? What?
She was.
Oh, I thought she was commenting on that. I try not to get too heavy into the weeds of mathematics. So anyway.
Now, tell me again, this is Regina. What's the name of that point? I can't
Okay,
understand it clearly.
Lagrange, Lagrange, and I'm assuming that some astronomer a few years ago, I think this is relatively new, I'm guessing, discovered and figured it out. And then we name it after him. I'm assuming it's a him.
Okay.
Yeah. All right. Let me just see here.
Could I add?
Yes.
something?
Yes.
Well, just because you were talking about fuel in the article, it mentioned that it actually used half the fuel that they thought it would. So now they think that we can keep it up there. We'll be getting things hopefully for 20 years instead of 10.
Thank you. That was on my list of
Oh, you saw that.
somebody
Okay.
that how long was it going to last, but I forgot who to ask. So maybe 20 years. All righty. We're going to go back to Jordan now for two things. I had asked him to look into the Doppler effect, and I want to mention first, we've heard of the Hubble telescope, which is still up there for what? Is it 15, 20 years, I think?
Yeah.
They didn't think it would last nearly as long, but it's still chugging along. Hubble was a famous American, I think, astronomer about 100 years ago. And they finally had gotten, when you think of the telescope that poor old Galileo worked with, compared to how much more advanced they have become. So by the time the early 20th century rolled around, Hubble, looking through the modern, and I forget where it was at the time, became aware of what he called the red shift. And this has to do with explaining first the Doppler effect that we hear with our ears. So Jordan, I asked you, you're in a city, you have police cars roaring by from time to time, and that train that runs down into Mexico goes chugging by from time to time. What was your experience of the Doppler effect?
Well, when I was looking up stuff about it, I didn't find any sounds of it, but from what I was looking at, it sounds different when moving away from you because the waves are stretched out.
Okay.
So it changes the sound. Whereas when it's coming towards you, it sounds different because the waves, where the waves are coming from is approaching you.
Right.
So it changes different because the waves are shorter.
Okay,
Like
we've all had this experience, either sitting at the train, the gate goes down and you sit there and the train goes by and he's blowing his whistle, or if you're in the city, the police car or the ambulance. And what you're right, as it's coming towards you, the pitch is higher. You've all heard it. And as it goes past you, the pitch drops, gets lower. If you're a musician playing, higher note, lower note. And the sound waves coming towards you, think of a slinky, are being compressed. Going away from you, the slinky is being stretched out. So it's longer wavelengths. Now, if we translate sound waves, the same idea, to light waves, on that spectrum, Roy G. Biv, who has the longer wavelength, the red or the blue? The red, Melanie says.
Red, yeah.
She's probably sat there in class in 3rd grade with her hand in the air. I got the answer. Okay, so the same thing is happening with light waves. If they're moving towards you, the pitch is higher, the frequency is higher. You have blue, you see the blue. As it passes you and starts moving away, then they elongate and become red. So imagine Hubble, you see, because I'm pretty sure most astronomers 100 years ago thought of the universe as some big, whatever, sphere.
Yeah.
That was static.
Yeah.
It kind of like was static. It wasn't getting bigger, you know. And he looks through the telescope and it's like, uh-oh, uh-oh. The further galaxies away, which we hadn't been able to see until these new, more powerful telescopes, we're all shifting not only into the red, but beyond the red and what's on our electromagnetic spectrum that's just below the red. Infrared. So that's why this telescope is not looking just at the redshift, but into the infrared as well. All right, Jordan, just for fun now, since we were talking about orbits and getting things up there, I asked Jordan to research and answer 4 or 5 questions about Tesla's car. So Jordan, you've got the spotlight.
Okay, Elon Musk sent his car into space in 2018. It was his 2010 Roadster. It was developed by Tesla, and they sent it in a SpaceX Falcon rocket. It was to showcase the power of their rocket. So the car now orbits the sun.
Oh.
And it has gone around the sun. I had the stat up. I think it's like 6,000 times.
What color was the car?
It's red, and it has a guy in it called Starman, or like a mannequin. It's in a spacesuit. So yeah, there's a site that gives constant updates on data about the car, like where it is and where how fast it's going. So it's traveling towards the sun at a speed of 6,118 miles per hour. And I think it's near Mars right now.
Now, wait a minute. Is the orbit, is the distance to the sun staying the same? Is it a circular orbit?
No, I think it changes. Well, it's around
going
Mars
towards
right
the sun.
now.
If it's going towards the sun, Mars is on further away from the sun, right?
I think it has a really big orbit around the sun because it says that it was near Mars, and it went near Mars also in 2020 in October. So I think it just has a big orbit.
So the orbit is either just a little short of Mars's orbit or a little longer than Mars's orbit. And by the way, Mars is in the morning sky. We'll get to Venus in a few minutes here. So Mars is now between us and the sun. I believe it's in the morning sky. Not sure of that. We'll have to look that up. Okay, so it's traveling around at 6,000 miles an hour, huh? In its orbit, roughly.
Yeah, well, that was the stat that they had for its speed approaching the sun.
Okay.
It also has one where it's going towards Mars at 16,518 miles per hour.
All right. If its orbit is slightly elliptical, like ours, our orbit around the sun. Remember that guy Kepler back in the whenever 1500s or so? Figured out if an orbit is an ellipse. I'm just trying to think. When we are the closest to the sun, we travel a little bit faster than when we are further away from the sun. So if it's an ellipse, when it's nearing the sun and going around the sun, it would be traveling faster than when it's further out. That's a wild guess. But I just think that's, I don't know. I heard about it. I saw a picture in some magazine, but somehow it just didn't register in the giggle level, you know?
And
But you must admit it was a great stunt.
must be nice to have that much money. To
That much money, right?
throw stuff into space.
Okay, what time have we got here?
That car's supposed to stay up there for millions of years.
Millions of
By the
years.
way, yeah, eventually they think it will crash into Venus or the Earth.
Into where, or the Earth?
Venus or the Earth, eventually, in
Venus.
millions
Oh,
of years. They
Venus
said in
or
a
the
million
Earth.
years there's a 6% chance it would crash onto the Earth or Venus.
Okay. You
But I
know,
think Earth was a 6% chance.
when you have nothing better to do and you're sitting contemplating the cosmos, if there are other intelligent beings out there, and like we who are archaeologists now and dig up, you know, let's say a site that's 400 million years old, our ancient ancestors, when they get to Earth and they see this car going around, I wonder what they will think. But anyway, is that it, Jordan, on Tesla and his great stunt?
Pretty much. I found a picture of the orbit and a description. It was an elliptical orbit that goes basically into the Earth's orbit, or right next to Earth at its closest, and just beyond the orbit of Mars.
All right.
At its farthest. So that would be on the other side of the sun. So it starts at Earth and then it goes past the sun a little bit out of Mars,
Okay.
his orbit, and then it comes back around to pretty much where Earth would be on the other side of the sun.
I don't know if we'll get to it in our last 5 sessions until next fall, but I want to spend more time on the NEOs, Jordan, that you had assigned a month or so ago, and we really didn't get to talk much about them, the near Earth objects. But I've been reading more since then, and there's something called, and if you guys are worried about this and lose sleep at night, that, oh my God, another one's going to hit like it did 65 million years ago, and I won't have to worry about my 401k. There are a bunch of asteroids that are not connected to the asteroid belt, and they have 4 different names, but they all cross our orbit at one time, or well, twice in their going around. And the chance of us being there at that spot in the orbit when they come by on that spot trajectory, that's what the group of scientists that are watching the skies now for these NEOs. Anyway, there are 4 different types, and they have 4 different orbits, one of which is like this one. It crosses between us and the sun. So we'll talk about those 4 and their names and how they go round, but that'll probably be not until next fall. Does anybody want to comment or ask questions about any of this before we get to our assignments for next time? What time is it, by the way?
1:47.
Okay. Questions before we move on to next assignments?
No,
You asked me, oh,
What's that, Sandy?
you asked me to find out, or why would we want to be looking at the origins of these galaxies?
Oh, yeah, okay.
I didn't find a lot, but I mean, the whole idea is like to plan for the future. Because we can learn like what is in store for us in a billion years, I don't know, a million years, whatever, you know, the whole process and how to prepare for it.
What about just plain old curiosity? You know, where would humans be if we weren't a curious species?
Yeah, yeah.
We'd
We
be-
can learn a lot, right?
We'd be
You
sitting in the
learn
jungle eating
tangential
bananas.
material, right?
What?
You learn tangential information, like you know, you're looking for one thing and you may discover something else in the way that's helpful.
Great. Well, I'm a curious person, and so for me, it's just fun learning all of this. If it has a practical aspect, you see, at least in our culture, unless it has a practical aspect, no one's going to pay for it. So one of the reasons, you know, NASA is what it is for the NEOs or for the Russians or for the whatever. Most governments do not simply fund pure science for pure knowledge. But often out of pure science comes very, very practical applications. So, all right, very quickie. It happened to be clear about 3 mornings ago, and I was up at 6 in the morning. Rima was probably up around 5 or 6. I know some of us get up in the middle of the night, and it was just beginning to get light in the east. And there was a morning star. And that got me thinking about Venus. So if you have a pencil, you might want to write this down. And I called up Ian on Sunday, and he did some finger hopping for me to come up with the exact numbers. I had the vague idea, but not the particulars. Think back to our ancient ancestors. It was fairly, you know, even if you lived at the North Pole, well, they didn't live at the North Pole in those days. The sun got up every morning and went down every night, and it was pretty steady. You know, maybe the days were longer in the summer, depending on where you lived. But it rose and it set. And then there was the moon. Now that was a little more complicated. That went through like a 30-day cycle. But once again, pretty obvious, easy to keep track of. And then they started with the stars, which also are very regular once you start keeping track of them. But then there were those things that we call the planets, and especially Venus, which is the brightest. And by the way, in the next 2 weeks, Venus is going to be the brightest it ever is at a magnitude of minus 4.7. And that's because of the phase it's in. Venus does phases just like the moon. And because it's as close as it is, it's as close to us as it is. And I forget how many years, quite a while since it's been this close, our 2 orbits. So it's going to be really, really bright for the following month or so. Early in the morning. On Saturday, the 29th, that's in about 4 days, there's going to be a crescent moon in the morning in the dawn light. And it's going to be on one of those days, give or take, quite close to Venus. So it's going to be a beautiful sight if it's clear. Now, I knew it was a Greek guy, but I forgot who, so Ian found out for me.
That
Way
was
back.
Saturday?
Huh?
I'm sorry, Mary Lou. Did you say that was Saturday morning?
I think so. Yeah, the 29th, I think is Saturday.
Okay.
It's the 29th, whatever day it is. Okay, back in the 500s, late 400s, BC, that guy Pythagoras, you remember, a squared plus b squared equals the square root of c squared or something or other. Okay. He also realized, what we call the evening star and then the morning star, they're the same thing. Because up until then, people thought of those 2 bright lights in the sky as something different. So here is the pattern for Venus, guys. It starts with when it's the evening star. It runs for 263 days as our evening star, rising close after sunset and each night getting a little higher at sunset till it reaches about 45 degrees up, halfway up, well, a quarter of the way of the half circle. And then it starts going back. So over that 263 days, it's our evening star. And then it disappears for 8 days. It's traveling behind the sun during the day. We can't see it unless there's an eclipse total. And then it pops up on the eastern horizon like it did at the beginning of January, the 8th of January, I think. And is our morning star. And each morning it gets a little higher till it's about 45 degrees up there. And then it floats back down again towards dawn. Then it disappears. This is what screws everything up. For 50 days. Don't see it for 50 days. And then at sunset, it begins over again as our evening star for 263 days. So I think the Mayans had this down pretty well, and some other ancient cultures. But it took a long time and a lot of figuring to get that strange pattern. And I'm not even going to try and think of what it's doing up there in the sky in relationship to us, that we have these 8 days versus 50 days when it disappears. Yes, Mary
Okay,
Lou.
but how long is it a morning star?
For 263 days, the same as it is.
No, that's evening star.
Both are 263 days.
That's the
Which-
evening.
Oh, I'm sorry, I missed that.
Yeah,
How
okay,
long is it a morning star?
263 days.
It's the same.
It's the same. What's different is the gap between when the evening star phase is done, which was at the end, just around the beginning of January, the end of December this year. It had been the evening star for about 8 months. Then there's an 8-day gap.
Yep.
And then it pops up as our morning star, which is it has done. And it will
Okay.
go now for another 263 days, which puts it around
Okay.
October or something. And then it will disappear for 50 days before it starts in again as our evening star.
Yeah.
Da-da. And because, once again, the geometry of space, of where its orbit is to our orbit in relationship to the sun, and the phase it's at, it's the brightest it's been. I'm sorry, I didn't write that down. Maybe I'll find it again and next time tell you, but it's been quite a while since it's been at magnitude minus 4.7. Remember, Sirius is magnitude 0, I think. And a lot of the bright stars we know by name are magnitudes 1. So this is really, really, really bright. Oh, questions. Gonna run out of time here. Questions for next time. Where are they? All righty. I'm gonna stick Rima with why is the sky blue? And Chris didn't sign in. So Rima's also gonna have to then tell me if she's standing on Titian, that big moon of Saturn. Why is its sky orange? Regina, you ready?
Yes, yep.
Oh, wait a second. Our whole topic is going to be atmospheric effects due to the sunlight. So we're combining astronomy, what's coming down from the sky, with what happens in our atmosphere. A rainbow. What's a rainbow? Why do we have rainbows? What has the sun got to
That's
do
my
with it?
assignment.
Yep. And what is the real shape of a real rainbow? Because we only see partial rainbows. Where do you have to be to see the whole rainbow, and what would it look like? Okay, Sandy. Halos that we see usually around the moon, but sometimes around the sun. What are the halos? How are they made? Okay. Okay. Mary Lou Cartledge. Sundogs and sun pillars. I see an empty chair. Where did she go? I see her head.
She's writing.
Okay, sundogs and sun pillars. What are they? When do we see them? What's our atmosphere like? Where's the sun? Oh, the pipels. Sorry, Ann and Bob, I'm giving you the toughie again. What's the role of ice crystals in our atmosphere that create these things that we see in the sky? So, Bob, basically, let's focus on 2 forms of ice crystals, the hexagons and the ones that look like pencils with 6 sides, columns. Okay?
Okay.
Because those 2 types, the hexagons, which are like a flat stop sign, or a 6-sided pencil, a column, they will produce different effects in the sky. Debbie. How do we get a double rainbow? Have you ever seen one, anybody? And Debbie, what's the order? Remember Roy G. Biv? What's the order of color in a regular rainbow? And what is the order in the double rainbow?
Okay, so how do we get the double rainbow and what is the order?
Of the color in both of them. Because a hint, they'll be different. Jordan, you still there?
Yeah.
Alrighty. We've all read stories about the intrepid explorers, and they've gone into the desert with their camels for whatever reason. And they've run out of water 2 days ago. The camels are dying. They're getting really thirsty. And off in the distance, they see, oh my God, there's a lake. There's some trees around it. If we can get there, we'll save our lives. And they trudge on and trudge on. They never get to the water and they die in the sand. So that's a hint. When you stand, Jordan, if you have a balcony that looks west, I forget what, I know your apartment goes east. So can you see out the west window to see the sunset or not?
I think so.
Okay.
From outside, yeah.
So in San Diego, if his apartment was tall enough or on a hill, he could probably see the ocean, the Pacific to the west. So he'd have a great view of seeing the sun go down. Now, Jordan, I'm not going to ask you to get up in the morning to see the sunrise, unless you want to stay up all night. But the same will be true for that sunrise as sunset. You're standing there watching the sun go down over the Pacific Ocean. Everybody can envision this. And there's a horizon between the water and the sky. And the bottom rim of the round sun touches the horizon and slowly, I think it takes about 2 minutes, sinks down out of sight into the ocean.
Okay.
That's not true. What you're seeing isn't there. Or the reverse, if you got up early in the morning and watched the sun come up, what you see coming up isn't there. Why?
Okay.
What's happening that you could say, but I saw it, I see it, I'm standing here, there it is, but it isn't. So what is it you're seeing? What's the atmosphere doing with our sight, playing tricks? Now, if anybody wants a hint, when this is over in a minute or two, go into the kitchen, get a glass, nice clear glass, fill it up with water, almost. Get a straw or a spoon, stick it in, and look at what you're seeing. Because what you're seeing is the same thing you're not seeing when the sun comes up or down. All right?
Yeah.
Yeah. Which means our day is really 2 to 4 minutes longer than it really is. And I have to double check if it's 1 minute while the sun goes up and down or 2 minutes. So that would make 2 or 4 minutes depending. I'll double check on that. All right.
Okay, next time is next week.
Yes, thank you, Mary Lou. Next time is next week.
February 1st.
That's right.
Oh, Groundhog Day. No.
So don't forget, I know we're having a lot of cloudy weather, but who knows? If you're up at 5 or 6, well, probably 6, maybe it's not up yet at 5, but by 6, it's still dark enough to see. Mars is also out there near Venus, a little bit under it, but not far under it. And by the way, in the middle of February, something's going to happen in the morning sky that happened 6 years ago. All 5 visible planets are going to be there in the dawn. I think the order is going to be,
when is that?
The middle of February, the 12th, I think. Mercury, Mars, Venus, I think Saturn and Jupiter are all probably going to be within close to maybe 2 hand spans of the horizon in the pre-dawn light. And of course, the one that's hard to see is Mercury, because it's so close to the sun. It comes up last, and it's closer to the glow, you know,
Mhm.
as the dusk fades, as the twilight fades. But hopefully somewhere along the line in there might be another crescent moon. I'm not exactly sure. So we can find some pointers. But once again, if Jupiter is so bright and we know where Mercury is compared to that, it should be easier to find, especially with your binoculars. Don't look into the rising sun with your binoculars. Okay. Any last comments? We had a full house today,
Sure did.
except for one new person that, Debbie, I mentioned to Bob about the sweatshirt, the birds.
Oh,
And so
yeah.
he's gonna put it in the newsletter.
It's so great. I love it.
Yeah, me too. All right.
See you next
Oh.
week.
Oh,
Mary Lou, did you also mention about the bird fossil with the pollen?
I mentioned it, but I'd have to somehow get a picture to you to run. Maybe I'll just keep it and have it to pass around in
Oh,
March.
yeah, that's a good idea. Sure.
And I have another wonderful thing on nests and all these incredibly different nests that birds make. Okay.
What did they put the red Tesla inside?
Inside what?